This will be a follow-up of a video I did on verifying identities. And I did two of the identities, this number 1 and number 2 here. And I said I would come back and do the other 2 problems that I had on this list. And I'll put a link in the description for that video in case you didn't see it. But these are the 2 that I did. So let's look at the first problem on this video, third from the list earlier video. And again, just to remind you, in proving identities, we said they usually start with the side that is more complex and use some basic algebra, some other fundamental identities, and derive the other side. So if you look at this one, we have the left side is tangent of x plus tangent of y over cotangent of x plus cotangent of y. And we want to wind up with tangent of x, tangent of y. So what to do? And I want to point out to you, in some of these types of problems, you will use techniques similar to what you do when you have radicals. So suppose I have 2 over the square root of 3. And usually when you're working problems with radicals, it's understood that the answer you give should be what they call rationalized. So they're not going to want a radical in the denominator. So for something like this, if you get an answer like 2 over the square root of 3, you want to write it without radical in the denominator, so we can say, well, let's multiply this by the square root of 3. Whatever you do to the denominator, you have to do to the numerator. Otherwise, you've changed the problem. As you can see, all we're doing here is multiplying by 1. Radical 3 over radical 3 is 1. 1 times the original fraction is still the same. So that doesn't change it. So then I could say this is then 2 radical 3. And the denominator becomes radical 3 times radical 3 is the square root of 9, which is 3. You can have a radical in the numerator, but not the denominator by rule. So this is then what you would give as your answer. Or if you have something like, say, 7 over the square root of 5 minus 1. How do we get rid of that radical there? Well, we can't just multiply by the radical 5, because you multiply by radical 5 eliminates that, but then you got minus radical 5. So we apply the conjugate, and multiply this by radical 5 plus 1. And we do the same to the numerator. Then it's legal. Again, we're just multiplying by 1, so we haven't changed it. So the numerator becomes 7 times, and I just leave this in as a product, radical 5 plus 1. And in the denominator, now we have radical 5 minus 1, radical 5 plus 1. And the reason we multiply by the conjugate here, that is the difference in the sum of the same 2 terms, is because we can apply the rule from algebra, basic algebra, a minus b times a plus b is the difference of the squares. So that would just mean I would square the radical 5, but that would just give me 5 minus 1 squared is 1. So you get 5 minus 1 is 4. So your answer then would simply be 7 times radical 5 plus 1 over 4. Well, you use the same ideas in some of these problems. So again, I picked the left side, that tangent of x plus tangent of y over cotangent of x plus cotangent of y is equal to this. Write it this way. Okay. So if I look at the right side of this identity, I can say that I had tangent of x. Another way to write this is tangent of x times tangent of y. That could be over 1. That's the same thing. So what do I have on the right side? In the numerator, I have tangent of x plus tangent of y. So what I'm going to do here is start with the left side. And since I want a tangent of x, and a tangent of y, the numerator, Let me redo this so I can have y. And I'm going to multiply the denominator by the same thing. Whatever you do to one, you have to do to the other one to make it legal. Tangent of y. Now, in the numerator, since I want to wind up with tangent of x, tangent of y, I'm not going to do anything there. Okay? I'm just going to leave it. So I'm going to leave it tangent of x, tangent of y. And I know that that tangent of x plus tangent of y has to go. So somehow I have to cancel it with whatever I get in the denominator. So I'm just going to leave that the way it is. Parentheses, and then just write it out. Okay, so now I have my fraction line. So now I multiply this out in the denominator. So I'm going to have tangent of x, tangent of y times cotangent of x, and then multiply it times cotangent of y. But notice, because when I multiply the first term, cotangent of x, because tangent and cotangent are reciprocals, okay, just like x and 1 over x are reciprocals. So whenever I multiply terms or numbers that are reciprocals, I'm going to get 1. So tangent of x times cotangent of x, that's 1. And that leaves me with tangent of y. Now the second term, again, doing the same thing, tangent of x, tangent of y times cotangent of y. Okay, again, tangent and cotangent are reciprocal. So here I have tangent of y, cotangent of y. Those cancel out to 1. That leaves you with tangent of x. Okay, so this is plus tangent of x. So what do we have? Tangent of y plus, this would be a plus here, plus tangent of x is the same thing as what I have up here, tangent of x plus tangent of y. They're in a different order, but addition is commutative, so those are the same. So I can cancel or divide out these two. So this then would give me tangent of x times tangent of y, which is what I wanted to come up with. That's the way you derive it. Now, you could also rewrite this. I'm not going to do it, but I'll just tell you, I could write this tangent of x up here as sine of x over cosine of x, tangent of y as sine of y over cosine of y, and then do the same thing in the denominator. Cotangent of x is cosine of x, sine of y. Cotangent of y is cosine of y over sine of y. So I'm writing everything in terms of sine and cosine, and then go ahead and find your common denominator for the expression then, because you're going to have fractions there in the numerator and the denominator, and then do the appropriate division, and again use your basic identities, and you'll come up with this also. You could probably also start with the right side if you wanted to and come up with the left side. Might be a little bit more involved, but again, you look at what you see. Do you see a formula or something that would make it easy to get the other side? So let's cancel this out, and let's look at the next one. 1 plus sine theta plus cosine theta over 1 plus sine theta minus cosine theta. We want that to equal to 1 plus cosine theta over sine theta. So again, pause the video if you want, see what approach you would take. Okay, again, generally we want to start with the more complex side. But sometimes, again, it doesn't matter. There might be a few more steps doing it one way or the other. But in this case, I went ahead and took the left side. And I found actually two ways to do it. I'm going to do it the first way, which I think is a little bit more simple, using the same idea that I used in the last one. Sometimes this method gets a little bit complex. You might want to go with another approach, use certain formulas that might simplify it, or identities. So what I did on this one, I started with the left side. So as I start this, I copy down I have the left side copy out over here, and I look at the right side. My objective is I want to come up with a 1 plus cosine theta in the numerator and a sine theta in the denominator. So what I did is I said, well, let me just put a 1 plus cosine theta in the numerator. So in other words, what I'm going to do is I'm going to multiply the 1 plus cosine theta times the numerator, the expression in the numerator, and of course I have to do it to the denominator. So basically what I'm doing is going to be 1 plus cosine theta times that expression there. Except I'm not going to do the multiplication out, because what I want is I want this to be in the numerator. So I'm hoping that when I multiply the denominator by 1 plus cosine theta, I'll be able to get an expression that will be equal to 1 plus sine theta plus cosine theta, and cancel those out. And also I want the sine theta in the bottom, in the denominator. So I want to wind up with also some factor of sine theta so I can get the final answer. Okay? So now, this is going to equal to, now I'm going to do the calculations up here. You really want to do it step by step. It's a little bit easy for me to just write it separately. So I'm going to say, okay, multiplying this times this. So first I'm going to multiply by the 1. So this will be 1 times that numerator. Well, sorry, I said I wasn't going to do that. So I don't want to do the multiplication. I want to do it in the denominator. So I'm going to say 1 times the denominator will give me 1 plus sine theta plus cosine theta. So again, it's this times this, but I'm not doing that multiplication. So that's going to stay factored out if you want. So I'm doing the denominator. So let me correct this again. So this will be 1 times doing the denominator. So 1 times the denominator will give me 1 plus sine theta. And this will be a minus there. And then cosine theta times the denominator. So that'll give me a cosine. So multiplying the denominator by cosine theta. So multiply by 1 there is cosine theta. And then cosine theta times sine theta. So that gives me sine theta, cosine theta. And then cosine theta times the minus cosine is minus. So I want to wind up then with this. I wind up with this here. Now, I look at what I have to cancel out. So I want the expression in the denominator to leave me with a sine and a factor of 1 plus sine theta plus cosine theta, because I need to cancel that from the numerator. So what I'll do is, of course, I know that cosine squared plus sine squared is equal to 1 of the same angle. So using that identity, I can replace the minus cosine squared by sine theta minus 1. Okay, so this minus cosine squared, I'll just write it out, that's been replaced by sine squared of theta minus 1. Again, I'm using the identity sine squared of theta plus cosine squared of theta is equal to 1, or if you want to say it the other way, cosine squared of theta plus sine squared of theta is equal to 1. So isolating the minus cosine squared, I can replace the minus cosine squared of theta by sine squared theta minus 1. So now we do some combining of terms here. This is all in the denominator, remember. So I got a 1 and a minus 1, so that cancels out. And then, now let me rewrite this here. So again, multiplying this out. So I got this times this. Remember, I didn't touch numerator as far as the product. I left that as factored form. So I have a 1 plus sine theta plus cosine theta. And then this is going to be being multiplied by 1 plus cosine theta. And the reason, again, I didn't multiply it is because I want to wind up with a cosine, 1 plus cosine theta there. And of course, a sine theta in the bottom. So now let's look at what I have up here. The 1's canceled out there, the 1 and the minus 1 over here. So this is going to leave me then with sine squared. So I get sine squared. All I'm doing here is combining terms. So sine squared. And again, this minus cosine theta here and the cosine theta here, those will cancel. Then I have a plus sine theta okay, from there, and then I have left what? The only term I have left is sine theta plus, here plus sine theta cosine theta. Now let's just factor. Everything has a sign. Remember, I want to wind up with a sign, because that's what I have over here on the right side. So every term has a factor of sine, so let's factor out the sine theta. And then I put parentheses, so this is a sine squared. I'm factoring out a sine, so that still leaves me with one sine. Here's a sine of theta. I'm factoring out a sine of theta. And remember, the coefficient is 1. So it doesn't leave me with 0. It leaves me with a 1. Plus. And then sine of theta. If it's factored out, I have still a cosine left over. So I get a cosine. Okay, so I can mark this out here because I rewrote it. So this is out. So this is what I have left in the denominator then is a sine of theta, and then in parentheses multiplied by sine of theta plus 1 plus cosine of theta. But that's the same thing as this right here. Okay. The one side in front, I could actually easily move this over here and write this as 1 plus sine theta plus cosine theta. So this actually divides out with this. So again, I'm not going to rewrite this, but what I have left is 1 plus cosine theta in the numerator, which is what I wanted, 1 plus cosine theta up here. In the denominator, things canceled out, I get sine theta, so I wind up with 1 plus cosine theta over sine theta, and that's what I wanted. When I gave this problem out as an assignment, one student that worked it out did it this way. He selected the left side also, and he wrote it out this way. He took the left side and multiplied the numerator and the denominator by 1 plus sine theta minus cosine. So you can look at this as a binomial and put parentheses here just to make it more obvious. And this is like, let's say this expression here, this 1 plus sine theta, that could be A, and this cosine could be B. And it's like this. So it's like, and look at this, this 1 plus sine theta, this is like an A here. Plus cosine, that's your B. So it's A minus B, A plus B on top. This is a plus here. So he multiplied the numerator and denominator by 1 plus sine theta minus cosine theta. So he applied this basic formula from algebra. If you have in the denominator, basically what you're going to have, he multiplied this one by, and this was a plus. So he multiplied by A plus B. Okay, so basically this is A and this is B. So it's A plus B times A minus B. In the denominator, it was A plus B and A plus B. So basically in the denominator, you have A plus B times A minus B is A squared minus B squared. In the numerator, you have A plus B times A plus B. That would be A squared plus 2AB plus B squared. Again, where the A is 1 plus sine theta and the B is cosine theta. But he's applying those formulas from basic algebra. And it gets a little bit messy, but when you combine your terms and reduce the left side, he got 1 plus cosine theta over sine theta. So again, there is more than one way to prove these identities, and that's why they're difficult to grade for an instructor, because the instructor might have a vision of one way to do it, and the student might decide to do it another way, or one student can use the left side and show how he gets the right side, or she gets the right side, or vice versa, start with the right and the left. So that's why these are tedious to grade, because you have to go through each one individually. But as long as you show step by step what it simplifies to, and it does give you the other side, then you get credit. The hard part about grading these is some students will start with one side and they'll do a few steps, and then the first few steps might be correct and so forth, and then all of a sudden they'll say equals, and they'll write the other side. Then you don't get credit. Okay, so you have to make sure that if you're doing a homework problem or working this for a test, that you make sure that you include every step so you get full credit. Thanks for watching. We'll see you next time.